3, 2, 1, liftoff. Or disaster. If we're talking data backups, failing to follow the 3-2-1 rule will probably result in the latter. So what is the 3-2-1 rule? It's a set of principles to protect you from data loss. Why should you care? Data is everywhere. You can always just make more, right? Well, data is the lifeblood of the modern enterprise. It's your secret sauce. Your customer records, quite literally, it's both your future and your past. And if you lose it, then it's going to feel like you're on that rocket that just crashed after takeoff. So let's take a look at the 3-2-1 rule to make sure this doesn't happen to you. And if you stick around to the end, I'll throw in a few more numbers I think you're going to want to know. Okay, let's take a look at what are the aspects of the 3-2-1 rule. First of all, there's a rule of 3 that makes up the 3 here. And it's basically that we need 3 copies of our data. Now, why is that? Well, we're going to have a primary copy of the data that we're working from. And everyone should understand you need at least one backup, because if you don't have that, well then if the primary fails, you've got nothing. But bear in mind that if this thing goes down, your one backup turns into no backups. So you're very exposed even still if you have only a single backup. A better idea, and that's just what the rule of 3 is saying here, is that we have our primary copy of the data, we have a backup copy, and we have another backup copy. That way, now if we have 2 backups and one of them fails, then we still have a copy of our data. So it's really simple. The rule of 3 here being have 3 copies of your data, even if at least one of those is what you're actually using in production. Now, the 2 portion of this says I need 2 different types of media. So I'm going to store these backups on different types of storage devices. Now, why would I need that? Well, hardware sometimes fails. So for instance, you might have stored this stuff on an SSD, solid state drive, and maybe that manufacturer had a bad batch of these and a whole bunch of them start failing. That's not hypothetical, that has actually happened. You're going to wish that your backups were on something else as well. So maybe we're going to put some of this on a spinning disk, on a hard disk drive. And maybe I even have it NAS attached, network attached storage. So different technologies that are involved here so that if one fails, they don't all fail. And maybe even one other option would be to put one of these in the cloud. So I don't even know necessarily what technology is there, but I know it's not the very same drives that I have here. So 3 copies, 2 different types of media, and now we get down to the 1. At least one of these needs to be off-site. Now, why is that? Well, because we can have things like natural disasters. If I have a fire, flood, earthquake, something like that, then it doesn't matter how many of these I have. If they're all in one place, they all go up in smoke, or they all get drowned, or they all crush from the earthquake. So I need at least one of these to be off-site. And that off-site, bear in mind, needs to have some geographical separation to it. So by this, I mean, I worked with a client one time where their main data center, their main offices were in New York City, and their off-site backup was just across the river in New Jersey. That's not geographical separation. If you have a hurricane, some massive winter storm that cuts the power to the whole area, well, then they're all going down. So maybe you have one in New York and one in Arizona, for instance. So you want them really separated that way. There's 3, 2, 1, 3 copies, 2 different types of media, and at least one of them off-site. But I've got some more numbers for you. And now 2 more numbers, 1 and 0. What do those mean? Well, the 1 in this case means that I need at least one of these copies to be immutable or air-gapped. Now, what does that mean? An immutable backup is one where, think of it almost like a diode, where I can write one direction, the data flows in one direction, but it doesn't go back the other way. So if I have a backup that is immutable, I can write out to it once, but then I can read from it as many times as I want. I cannot overwrite that same. Now, I can still keep writing to the same storage, but it just keeps appending and adding more to it. Now, what's the value of that? Well, if I have ransomware that has infected or encrypted my original copy, then it would be nice to know that I have a copy that it cannot also encrypt, because once it's been written, it can't be changed. So that's one example. A lot of organizations will say, yeah, but we do air-gapped. Now, what is air-gapped? Means just exactly that. A lot of people that say they have air-gapped systems really don't. An air-gapped means that. It means there's air. There's literally no connection between these two. So at some point there was a connection, and then we separated them. And at the point we separated them, we took a snapshot. And this will forever now be locked in that time. In other words, the disadvantage to this is that it will not be current. It will always be a snapshot, and therefore will always be constantly falling further and further out of date. The example with this is we can continue writing and not worry about it being overwritten, so it's still protected, but the big advantage here is I can keep writing out more copies, so it will be more up to date. But you need at least one of those to be immutable or air-gapped so that it can't be changed after the fact. And the 0, you ready for this? We want none of these, no errors. Now, how does that happen? Well, I'll tell you, for instance, I worked with a bank one time, and they had done a good job of backing up all their data, but what they didn't do was test those backups. And once they had a disaster, they went to go pull all the data from their backups, they had nothing. All of the data was useless. So it's not enough to just do 3, 2, 1, 1. You also need to go back and periodically test those things, verify that recovery in fact still works. Then if you have all of these things, you've got something that will really work. Oh, and there's another thing. Across all of these, what should we do? We should encrypt these backups. Because if we don't, someone may get a copy of one of these backups and then be able to read what might be our sensitive information. So encrypt, and you'll notice one of the things that I'm verifying or maintaining, one of the characteristics of this whole thing, is I have no single points of failure, because a single point of failure will come back to haunt you. So assuming we do all of this stuff, what are the benefits? What's the payoff for us? Well, it means we have, among other things, protection against disasters, disaster recovery capabilities. So as I mentioned, the fires, floods, and things like that. It's basically Murphy's Law, which says anything that can go wrong will go wrong. And that's especially true when it comes to backups. Another thing we're trying to guard against are attacks. So where Murphy's Law is looking at accidental things that just happen in an imperfect world, attacks are intentional. This is where someone's done ransomware or hacking into your systems and things like that. So if they've done that and I have sufficient backups, if someone does a ransomware attack and they say, I've got your data and I'm not going to give it to you until you pay me, if I say, I've got a copy of my data too, you can go pound salt, then we're covered. And then the other thing we can do is minimize downtime. And every organization, whenever I ask them, how much downtime can you have? What kind of availability requirements do you have? Guess what they all say? We need 24/7 by 365. And I'm thinking in my head, you mean 365 and a quarter, right? You don't want leap day to be not working, right? So, but that's a laudable goal. But if you really thought about what that costs, in other words, if you never have a second of downtime, here are some numbers just for you to consider. If you have 99% uptime, you know how much downtime that means in a year? It means 3 days. So 99% sounds pretty good until you started looking at that. 3 days of downtime could be crippling for an organization. So we call those 2 nines of availability. What about if I have 3 nines of availability? What does this lead to? Well, this is going to give us 8 hours of downtime. So basically a whole workday almost that's going to be down, even with 3 nines of availability. How about 4 nines of availability? Surely this will make everybody happy. Well, 4 nines will give you 52 minutes of downtime. It's almost an hour. Now maybe that's good enough in a lot of cases, but in some it won't be. Let's say we go all the way on out here to 5 nines. Now what are we going to end up with? 5 nines gives us around 5 minutes of downtime. So this is something, maybe it would be tolerable. There are some cases where even that might not be acceptable. But the bottom line is every single one of these has a cost. And the further you move down, the more cost it is. And the more you want to have the downtime minimized, the more you're going to have to invest in backups. That's a huge part of all of this. So the bottom line is that you're going to have outages. The question is whether your environment will be resilient enough to weather the storm. Following the 3-2-1 backup rule is a great start, and adding a few more digits to the plan will make it even better.